As an anaesthetist, you often have to go in the back of an ambulance with a critically ill patient on a transfer to another hospital, and you have to take oxygen with you. And one of the exam questions that comes up a lot is how much oxygen do you take with you and in what form? So I thought I'd go through it. So first thing to consider is that your patient and your ventilator both have requirements. Your patient is obviously consuming oxygen for their metabolism, but your ventilator will often use oxygen for its driving pressure to actually ventilate the patient. Now, some ventilators don't need to use oxygen, they can use room air around them. It's really important you know for your model whether it's going to use your oxygen supply or if it's going to use room air, so you need to check that. For this one, we're going to assume that the ventilator is using oxygen. And of course, because they love testing your knowledge of numbers, you need to know all the different cylinder sizes and how much they contain. So I start with a C cylinder, which contains 170 litre. Then you double it, D gives you 340, double it again, E gives you 680. Then there's a jump, F gives you 1360, and another jump, G gives you 3400. These are enormous cylinders. Usually we see sort of E and D size cylinders in hospital. So our equation is, we need to know how much the patient's going to consume, we need to know how much the ventilator's going to consume, and we need to know how long our journey is going to be. So let's say we're going to go on a 6-hour transfer, and our ventilator on the manual says it consumes 400 millilitres per minute, or 0.4 litres per minute, to drive the ventilator for the patient. So how do we calculate how much the patient's going to consume? We need to know how much they're breathing and what percentage of that is oxygen. So we take their breaths per minute and their tidal volume, so how much each breath is in terms of volume, and then we times that by what percentage of that breath is formed from oxygen. So our patient is breathing at 14 breaths per minute, 500 mils per breath, and 40% of that is oxygen. So that works out at 2.8 litres per minute. When you're doing the calculations, make sure you're not getting mixed up between millilitres and litres. So I convert everything to litres. So I would say 14 times 0.5, and then the 40% should go as a fraction or a decimal, so 0.4. So 14 times 0.5 times 0.4 gives you 2.8. So you add those together, patient consumption plus ventilator consumption, and that gives you a total of 3.2 litres per minute. Then we need to know how many minutes. So it's 6 hours of 60 minutes, which gives us 360 minutes. So our total consumption, if you add that all up, gives us 1,152 litres of oxygen that we're definitely going to need. Now, this is assuming all goes absolutely well, the patient doesn't change their requirement, the ambulance doesn't have any problems, there's no traffic, etc. You do not want to take 1,152 litres because you will be panicking the whole journey. You need to take a lot more than that so that you've got a buffer in case anything changes. So essentially we say double it. Some places say take 1.5 times what you've calculated, but most places say just keep it simple, take double what you need. So we're going to double it and round it up to a sensible number. So let's take 2,400 litres of oxygen. Now, to make 2,400 litres of oxygen, we've got several options. We could take one G cylinder, that would be more than enough. But a G cylinder is enormous, and it's risky only taking one cylinder, because if you have a cylinder failure, you are then stuck with no oxygen whatsoever. And 2 G cylinders would be silly amounts. So we could take 15 C cylinders. Again, 15 cylinders is silly and it's going to be impractical. So your sweet spot is probably 2 size F cylinders, will give you more than enough oxygen. It's easily manageable. And if your cylinder fails, you've got a backup, and 1,360 should be more than you need anyway. So even if one of your cylinder fails, you should have more than enough. So that's your safest and most practical way of carrying enough oxygen.